Into our conversation from chapter 4, and the purpose here is to talk more about, can you guess, concentrations. All right, so the interesting thing about this, or maybe I should say the easy thing about chapter 12, section 5, is going to be that all the concentrations are going to be framed in terms of a part per whole. Okay, so the part per whole, you've heard me use this language before, just using slightly different technology today, so there may be a bit of a learning curve. Part per whole. And we're going to constantly be asking about the part per whole, right? So the part per whole in molarity, which we were introduced to in chapter 4, the part was the moles of solute, right? And the whole was liters of solution, okay? Now we need another term, molality. For now, by the way, we're just going to memorize these and use them. A bunch of these are going to be, I think, relatively accessible. They're going to make sense. But molality, in my opinion, does not. It simply has to be memorized. And molality is going to be the moles of solute per, watch this, kilogram of solvent. All right, and so the units are here for molarity, here for molality. Mole fraction, this totally makes sense. Mole fraction is going to be signified by the Greek letter chi. That's a lowercase x in the Greek alphabet. This is going to be the moles of solute for the moles of everything. And that's what fraction means, right? That's what fraction means. This is good. This will make some sense. Mole percent is the same thing as mole fraction, except it's converted into a percent. The parts by mass is mass solution over mass of solute over mass of solution, and that's parts by mass, and then by some multiplication factor. And here are the examples. Percent by mass, which is parts per 100. I'm going to write that down here. This is parts per 100, which we typically call percent. And then we have parts per million, parts per billion. Occasionally, if you're looking at some really super toxic substance which is in the public water source, you might see parts per trillion. Okay, and then we also have parts per volume, which can be ppm, ppb as well. All right, so it's the multiplication factors for. It's important to note here. I guess I'm going to point it out to you and ask you to read it. But I don't want to make much of it. So let's do a couple of sample problems, and then we'll be done with this section. I'm sorry. I did want to point this out to you. This shows up in chapter 12, but it was also in chapter 4. This was how to, let's see, where are we here? This was in chapter 4 and chapter 12. And it's essentially how to make a 1 molar solution of sodium chloride, right? So what we do is we take 1 mole of sodium chloride, okay, put the solid in here, pour it in here, and then we take a 1 liter volumetric flask, and looks like it's 1.0023 sig figs, okay? That's the 1 liter mark. We fill the water up to there, so you see everything in here is both solute plus solvent, which is equal to solution. Can you read my writing? And this is 1 liter. So you have 1 mole of sodium chloride in 1 liter of solution, right? And moles per liter is equal to 1 molar. Okay, so you've seen that before, and I think that might have been in the video for chapter 4, section 4. All right, but just wanted to remind you about how we're making those things. Now let's look at the first sample problem. Using parts by mass. What volume in mils of a soft drink that is 10%? Okay, so the concentration is equal to 10.5% sucrose. So I'm just going to call S. Do you mind if I do that? S by mass. contains this much grams of sucrose. Okay, so let's first thing I'm going to do is I'm going to take this this number and I'm going to define it. It's 10.5, and this is percent by mass. Okay, so it's 10.5 grams of sucrose per 100 grams of what? Soft drink, right? Okay, and the question is, what volume contains this much sucrose? All right, and then the other thing we're given in the question stem is that the density is equal to 1.04 grams of solution per mil of solution. Okay. All right. So let's do this out. Now the question is, what volume in mils of the solution, right? So the answer is going to be mils of solution. And suppose I had no idea what to write, I would simply start here. Moles of solution. Then I would look up in my question stem. Oh, I'm sorry. There's one more thing to write here in my key, and that is the mass is 78.5 grams of sucrose. Okay, so I'm going to come up here now and look at my key. Here's my key right here. And I'm going to say, where do I see mils of solution and what's it related to? So it looks like mils of solution here is related to grams of solution. So this is, let's say that's factor 1. And this is factor 1. It's actually the reciprocal of factor 1, right? So mils of solution looks like it's related to grams of solution. Okay, do you see how I'm not putting the numbers in yet? Right now we're just going to do the units, okay? So mils of solution is here, and it's here. I got to cross off grams of solution though because it's not in my answer. Grams of solution, and I see, aha, here's grams of solution right here. What's that related to? Grams of solution, it looks like this is factor 2. So it looks like it's 1 over factor 2 right here. This is related to grams of sucrose. You see that? So grams of solution are going to cross off. We'll do that in a second. And now I've got to cross off grams of sucrose. Grams of sucrose. And what's that related to? Nothing. It's just a measurement. Okay. So this looks like it's factor 3. I'm going to write it here. Okay, so this is factor 3. This is 1 over 2. Can you see if I do this now? These are going to cross off. These are going to cross off. And I'll be left with the units that I want. Wow, beautiful. So let's put the numbers in now. Where did I get grams of sucrose? Well, that's from factor 3. So this looks to be, mind if I write it down here below? 78.5 grams of sucrose. And this looks to be, this grams of sucrose per gram of solution, so it looks like it's 10.5, 100, right? Can you see why that? You see how the grams of sucrose is on the bottom? It's on the top here, so I got to invert that. And then grams of solution per mil of solution is here. 1.04. Okay, and I gotta grab my calculator. So it looks like it's 78.5 times 100. 78.5 times 100 divided by 10.5. 10.5 times 1 divided by 1.04. Is that right? 718.86. 718.86. This gives us 718.86 mils of solution. Okay, let's go through and see what our sig figs are. There's 3 sig figs here, 3 sig figs here, and 3 here. Okay, so this is a definition. So there's an infinite number of sig figs here, right? That's because that was our percent. 3, 3, 3. So this is going to be 3. So this needs to be written as 719 mils of soft drink. And that is our answer. Wait. Okay. All right. That's our answer. 719 mils of soft drink. Okay. Okay. So now let's do another example, this time with a different kind of concentration expression. Let's look at this. A solution is prepared by dissolving 17.2 grams of ethylene glycol. Okay, so the mass. Oops. You know what? Let me go to red. Can I go back to red? Okay, so to write our key out, the mass is equal to, oops, wrong problem. Point two, I'm going to write this in grams over here, okay? Grams. And the mass of the, mass of water in kilograms is equal to 0.5. All right, the final volume of solution, the volume of the solution is equal to 515 mils. I'm going to do this in liters, okay? For this solution, okay, molarity. So we've got a lot of things to calculate here. So first of all, molarity. Molarity is equal to moles of solute per liter of solution. So this is going to be, oh, I don't have the moles of this. I need to find the moles. So the moles are going to be, and we need formula weight for that. This is in grams per mole. The formula weight is equal to 2 times carbon plus 6 times hydrogen plus 2 times oxygen, which is equal to 12.01, 1.008, and 16.00, which is equal to 24.02 plus 048 plus 32. Oh, I can't do this in my head. Yeah, I can. This is 30.068 plus 32, which is equal to 62.068. I'm definitely going to need a calculator for my next one, okay? Grams per mole. And so the moles then, which are here, is going to be the mass, which is 17.2, divided by 62.068, which is equal to what? 17.2. You really should calculate this yourself. Please pause the video and calculate it. 17.2 divided by 62.068 is equal to 0.277115. Okay, we're going to keep all those numbers in the calculator for now. All right, and so what we have up here is the moles of solute is 0.277115 divided by the liters of solution, 0.515, which is equal to, divided by 0.515, 0.538. Molar. Okay, I give myself some more room here. B, mole fraction. Oh no, molality. Okay, that's moles of solute over a kilogram of solvent which is equal to 0.277115 divided by kilograms of solvent, which is 0.5, which gives us 0.5, oops, yeah, 0.55423, 0.55, oops, we got 3 sig figs here though, right? 3 sig figs for everything. 0.554. And this is mole, and it's a lowercase, and it's usually italicized, so I'm going to underline that. Okay, C, percent by mass. Oh man, what a pain. Okay. Well, it's not actually so bad. C, percent by mass, is the part per whole. The part is the mass of the ethylene glycol. And so that's 17.2 grams. And the whole is the ethylene glycol plus the other, right, which is 500. Okay, now these are in grams and grams, so those are going to wash out and they don't matter, but we have to say times 100% is equal to 17.2 divided by 17.2 plus 500 times 100 comes out to 3.325599. I'm going to shortcut a little bit here. 3.33%. Okay, let's do another one. Mole fraction. Oh no. Okay, I got to find the moles of water. So this was the moles of the solute. Now the moles of the water. I know this is hard to read. Oh, it's terrible. Moles of water is equal to 17.2 divided by 18.016. Which is equal to 0.9547. 9547 moles of water. Okay, so the mole fraction then is going to be the moles of the part, which is 0.277115 divided by the whole, 0.27115 plus 0.9547, which is equal to what? Okay, now listen, if you don't know what I've written here, I realize that's messy. I can hear a student saying, hey, what did you write there? I would say, well, actually, please don't even ask. You've got to go back and look at that. Why did I write what I wrote there, right? So ask yourself, you really should be pausing the video and trying to do this problem before you come to my solution. I know, that's very, very terrifying, but you need to try it. 0.27115. Oh, 277,115 divided by 0.277,115 plus. Okay, so the mole fraction, it looks to be, comes out to be about 0.22. Before I do this, I got to go back. Mole fraction, make sure I got this right. There's my moles, 277,115 right here. That's my part. And then the whole is both the solute and the solvent. Okay, and sure enough, that's right. Okay. And this, I'm going to write this to 3 sig figs, 0.225. Okay. And E, mole percent. Oh, I just take that and multiply it by 100. Wow, that wasn't nearly as bad as I feared. Okay. So, calculating concentrations, we did a lot of problems there. Please consider rewinding that and looking at it again if it doesn't, if that's not what you got. Of course, I'll go back, look later myself and see Make sure I got the right answers. Let me do that now. Okay, so Trove disagrees with this problem here. I'll go back and check it later. Trove disagrees with this problem here. Oh, you know what? This was not my mass of water. This was a mistake. It was supposed to be 500. So these two both are not correct because I used the wrong mass, right? This was the mass of the ethylene glycol, and it was the mass of the water I was supposed to use. All right, so I'll do that again later on request, but D and E are both wrong because they used the wrong mass. Okay, I hope that's not terrifying. Okay, I'm going to move on. Converting between concentration units. Okay, so what is the molarity of a 6.55% mass glucose and the density is such and such? I'm going to do the same thing I did last time, try to be a little more careful because when you start a problem out like this, you really have no idea. I have no idea what's going on. So I'm going to first of all write, let's see, the molarity. Let's say the concentration is 6.55%. which is the same thing as 6.55 grams of glucose. I'm going to call that capital G over 100 grams of solution, right? Okay, now, and we're given and all I did so far was I just defined what's meant by that term there, percent. It's just defining that. The density is 1.03 grams of what? The density of the solution, right? So it's solution per mil of solution, okay? This might be all I need. So the question is, what's the molarity? Oh, I don't know. I do need also the formula weight of glucose because I need moles, okay? So formula weight is 6 times carbon plus 12 times hydrogen plus 6 times oxygen, 12.01, 1.008, and 6 times 30. 6 times 16 is, I don't know. I'm going to do this with my calculator. Six times 12.01 plus 12 times 1.008 plus 6 times 16 is equal to 180.156. We've done this before, but I never remember it. 180.156 grams of what? It's glucose per mole of glucose. Okay. Now watch, I have a feeling that if we just simply start out here, let's try this first. Let's come down here and say, what is the molarity, okay? That's going to be moles of the solute, which is glucose, over liters of solution, okay? So I'm going to go here and first of all put moles of glucose because I know I need it in the end. So I come up here and I see grams of glucose. Aha, here's moles of glucose right here. I'm going to call that factor 3, and this will be, looks like 1 over factor 3, right? Can you see that? Because it's going to be related to grams of glucose. Okay, now there's no grams of glucose in my answer, so I have to cross it off. And I already used number 3, so let's come up here. Aha, here's factor 1. It's got grams of glucose in it. And what's it related to? Looks like that's related to grams of solution. So these will cross off in a minute. Grams of glucose per gram of solution, that looks like that's factor 1, right? Now I don't have grams of solution in my answer, so I've got to cross it off. And sure enough, look at that. It's right here. Grams per mil. Okay, I'm sorry, I've got to do that. Grams, what's it related to? Mil of solution, right? That's factor 2. Grams per mil, and it looks like I've got to cross off mils because it's no mils in my answer, but it's liters here, liters and mils, and there's 1,000 mils per liter. This is just a conversion that I know, all right? Okay, so let's change the color to black, be done with it, and decide if I've got to go back and make another video for the mistake I made in the past problem. Okay, so let's put the numbers in here. It's 1,000 times grams per mil, and the grams per mil is 1.03 per 1, and it's grams per gram, and those are, where are those? Those are right here. So it looks like there's 6.55 grams per 100 grams of solution, right? And then here it looks like I've got 180.156 grams per 1 mole. Oops, that was supposed to be 1,000. Wow, I mean it was supposed to be 100. See, here's my 100 here, and I just put 1,000 there on accident. Got to be careful. All right, so I'm going to get rid of that and change this to 10. Okay, I'm going to get rid of that and change this to 10.3. And that's all the shortcuts I'm going to do. Let's put this in here, 180.156. So it looks like it's 10.3 times 6.55 divided by 180.156 gives us 0.37448. 0.37448, and it's 3 sig figs, and a bunch. I got these from the periodic table. So this is going to be 3 sig figs. So this is reported as 0.374 molar. All right, and there is my answer, 0.374. I hope that is helpful. I do, again, I say, I regret that I made an error in the previous problem, but it's probably a good example of how easy it is to make one. If you want to see it worked out correctly, let me know, and I'll certainly do that, make a video for it. I think that's it for this video.